Hello everyone, today we will discuss about center of mass of a dynamical system. The center of mass of an object of mass m is the single point that moves in the same way as a point of mass m would move when subjected to the same external force that act on the object that is if the resultant force acting on an object of mass m is F, then the acceleration of mass of the object or system is given by acceleration of the center of mass is equal to F external upon capital M. The general formula for a system of n particles the position vector for center of mass can be written as sigma I is from 1 to n mi ri minus r equal to 0. Here you can find the position vector of the center of mass, that will be equal to sigma I mi ri upon sigma I mi, where I is from 1 to n and here is I also from 1 to n. So it can be written as sigma I is from 1 to n mi ri upon capital M, where M is the total mass of the system. For a system of two particles, we can write the position vector for the center of mass let us say it is mass m1 and its position from the origin of the coordinate system is say r1, and there is the other mass of m2. Its position from the center of the coordinate system is say r2. Then if we define the center of mass somewhere here for this system, and let us say its position vector from the origin is r, then we can write the position vector r for two masses m1 and m2, like it will be m1 r1 plus m2 r2 upon m1 plus m2, or we can write it as sigma I is from 1 to 2 mi ri upon sigma I is from 1 to 2 mi, right? Our earlier formula that d2 over dt square sigma I mi ri is equal to Fe. Here Fe is the external force. So if we use this relation to the two mass system, then we can write R. First we will write that formula. R is equal to sigma I is from 1 to 2 mi ri, sigma I is from 1 to 2 mi, or we can generalize it sigma I mi ri upon sigma I mi. So here we can write it as sigma I mi as capital M, so it becomes mr is equal to sigma I mi ri. So if we differentiate it two times with respect to time, then the relation becomes md2r over dt square is equal to d2 over dt square sigma I mi ri, and use the external force. So here d2r over dt square is equal to Fe upon capital M, where capital M is the mass of the system, and this is called as the acceleration of the center of mass. The object is, now let us say, if the object is composed of tiny masses m1, m2, m3 and so on, and their coordinates are x1, y1, z1, x2, y2, z2, x3, y3, z3 and so on. Then the coordinates of center of mass can be written as xcm is equal to sigma I xi mi upon sigma I mi. YCM, y coordinate of the center of mass, it is equal to sigma I yi mi upon sigma I mi, and ZCM is equal to sigma I zi mi upon sigma I mi. Extends over all masses. In a uniform gravitational field, the center of mass and center of gravity coincide. Suppose it is an object and it is placed in a uniform gravitational field. Then the center of mass and center of gravity both these coincides. But in non-uniform gravitational field, the center of mass of an object and center of gravity may be at different points. It is center of mass and it is center of gravity. If an external force is applied on center of mass, then it can use linear acceleration without angular acceleration. Next thing is center of mass is also called as balance point. Of an object. The center of mass may be located outside the physical body, such as in case of a ring, that is a closed shape hollow object, and horseshoe, that is open shaped object. It is open shaped object. So it is not necessary that center of mass may be located inside the object. It may be located outside the object. In case of planets, of solar system, it is not necessary to correspond to the position of any individual member of the system. Center of mass is a useful reference point in mechanics for calculations. Thank you.